The goal of this lab was to observe the motion of a falling object and model it using Newton's second law and the momentum principle. I was filmed jumping off of a 5-meter diving board. The model was pretty close to the actual data. To create the model, I analyzed the video using Tracker and used Newton's second law to create a program in VIDLE. Unlike in Lab 1, this lab does have a net force because there is a change in velocity. The two forces we are focusing on today are gravity and drag. The force of gravity is equal to 9.8 times the mass, while the force of drag is equal to the velocity squared times a constant -b. So as the velocity increases, so will the drag force. B is negative because it has to be in the opposite direction of the gravity. For my initial conditions, I'm setting the position equal to 0, 0 and the mass to 56.7 kilograms. For my first run, I'm setting my B constant equal to 0 because we want to see what happens when there is no drag force acting on the model. As you can see, there's a slight discrepancy between the actual data and the model predicted using VPython. So when I go back to my code, I add my B constant, which through trial and error was found to be 2.5. J-hat was set to 0, 1, 0 to choose the orientation of the y-axis. As you can see, this fits the model much better than the one without drag. When I extend my models out to 20 seconds, you can see a clear difference in the velocity. While the velocity with drag levels out at about 14.9, the velocity without drag keeps increasing at a constant rate. The velocity of the model with drag levels out at its terminal velocity. It occurs when the force of gravity and the drag force are equal to each other, causing an F-net of 0. This makes the velocity constant. But what would happen if an object was thrown down? To model this, I set the initial velocity of my model equal to 0, -5, 0. What happens is that the object reaches terminal velocity more quickly than it would have if it were not thrown down.